thank you very much. This is a unusual place for me to be talking. I'm not used to talking to people of your age and your variety and things like that. If there's any questions or any discussion people want to have, I'm very happy to stop and answer any questions or talk about what anybody wants. But I hope to talk about three things today. And I gather I've got about 45 minutes is what I am told. And the three things I want to talk about a little bit are, what is this area of data science? I think you've already had some lectures here about a new area, about people working in data science. I want to try to talk a little bit about what that is. I want to then talk a little bit maybe more technical about how you use computers to help understand natural language, which is one of the things that people do in data, a data science-y way, a machine learning-y way to understand how language works. And finally, give you some personal advice. If some of you are interested in becoming, really getting into computer science on some level, what would be the thing that I would recommend high school students do if they really wanted to be hotshot computer science people? And that's what I'm hoping to do today. Okay, so what is data science? Okay, data science is this field that is kind of an emerging buzzword type field. It's a new thing. Why is it emerging, or what is it? It's kind of a mix. New fields kind of get formed at the intersection of existing topics. And, what I would say data science is a lot about how do you do statistics, how do you visualize data, how do you make sense of data. There's a large component from machine learning. Some of you have how many people have heard about machine learning? This is kind of the big thing in the news. Machine learning is going to take over the world. This is one of the things that is driving data science, is that there's a lot of interesting things in machine learning. I'll talk a little bit about it. And the other thing is that kind of as computers keep getting bigger and networks of computers keep getting bigger, there's kind of now very large-scale resources. People can do very large-scale computations on massive amounts of data, and this enables you to do new things. And so part of the thing is that there's new data sources that are collecting massive data that didn't exist before. And so people now have data analysis problems on wildly bigger scales than before. What are all the queries in Google? What can you learn from looking at that if you're Google? If you are doing social media, if you read all the social media posts of all the people in all the world over years, what could you learn about the world from that? This kind of thing. So that's one of the things that makes it powerful. And the other thing is a lot of people are, basically there's been a lot of successes from data science. How many people's parents work for hedge funds? Does anyone know, or financial funds or anything like that? Nobody. Okay, so I read my crowd wrong. But my instinct is that there's lots of fields where people are doing, large-scale data analysis, on all kinds of different scales, sports, finance, all kinds of things. And so what is data science? Again, this is kind of a Venn diagram. I suspect many of you know these things. It's kind of measuring the intersections of different sets. I would say that data science kind of sits at the intersection of computer science, statistics, and some kind of a domain. So people use data science applied to biology or to social science or something like that. If you don't have a problem in the world you care about, you're not really doing social science on some level. That's kind of the domain area. And, there's different things, tools we learn, machine learning. It's important to know about all these things. If you don't know about all these things, you can't do certain studies the way that you would like. So I work in computer science. I'm a computer scientist by training. And I guess when I look around here, I see test tubes, I see I see lots of real science. I see there it is, real test tubes, real science going on. What is the difference between computer science and a real science? Okay? One thing is that computer scientists kind of live in a make-up world. Computer scientists are learning how to use computers, program computers. Everything's very well defined. Everything behaves the same way every time you run it. When you do an experiment like that, sometimes the thing works, sometimes it blows up. There's different levels of noise and confusion in the world. Computer scientists study a well-defined world real scientists study a messy world. And kind of data science is trying to use computer science ideas to study messy parts of the world by looking at data and making sense of it. And maybe I won't go through that anymore and really talk about it. You know, one of the things that, again, there's a difference between computer science and data science. In computer science, people typically think their job is to build software. Whereas in a real science, kind of people think of their jobs as to understand the world and try to explore the world and things like this. And so kind of what data science is I want to say, if I have to carry away an idea, I think of it as using computer science-y techniques to try to understand how the world works. And with all this said, I want us to now pretend that we are real scientists and try to solve a problem that, study a problem that some of you may be aware of, okay? How many people have parents who complain that you guys don't get enough sleep during the school year? So this one I got right, okay? Suddenly everybody is like this, okay? And so I'm imagining in your home when your parents are complaining, oh, your kid, you don't go to bed too late, you don't get enough sleep. And you say, no, I got to study for my test. I got to do well on my test. I'll do well by studying, staying up late and getting sleep. Now, the question I want to ask is, suppose you wanted to do a study. I want us to pretend to be scientists. No, not pretend, to be scientists here. How would you figure out whether sleep affects performance on things? How would you do this? This is not a physics question. This is now, how would you do a scientific study to try to gain insight into whether sleep affects performance? Any ideas how people would do it? Yeah.
How would sleep grades on tests?
You're saying, how would sleep affect grades on tests? That sounds like an interesting study to do. How would you do this experiment? And again, when you talk to people who are real scientists and how they do experiments, they worry about things like how much money will it cost to do the experiment, okay? They will worry about things like, is it ethical or not? Like one possible way that you could conduct an experiment like this is you take half the class, put them in a room where they're not allowed to sleep, okay? And then after 36 hours of being awake, you make them take a test. These people, half of them would die. So that would not be an ethical experiment. Everybody kind of see that? How would you go about trying to get insight? So let's now continue to try to look at this. Can anybody think of ways you might be able to study this question, how sleep affects people?
Perhaps you could use actual data from schools and ask students from a certain school, different schools around the country, how much sleep they get, and and maybe choose a certain class. Maybe choose mathematics, since everyone takes mathematics usually around the country, and so check to see whether the grades of mathematics correlate with sleep, and maybe try getting other data.
Okay, so you're saying basically conduct a study by asking people what they did in how much sleep they got and how they did on tests. Okay, and that's a reasonable thing, except for one thing: is that people lie. People lie. So sometimes people often get confused. How much sleep do you get at night? Oh, I don't know, okay? You tell your mother, you're going to tell her that you got more sleep than you probably actually did. When you're bragging to your friends about how you pulled the all-nighter, oh man, I didn't get to bed till 6 in the morning or something like that, okay? So people lie, they lie like drugs. That's a limitation for that kind of a study, okay? Yes?
To avoid lies, I would suggest taking some kind of standardized test that goes around the entire country, maybe an AP test or something kind of similar, or SAT, and just put a question when people are filling in their information. How much sleep did you get last night? So
one possibility is if you took a broad test like SAT and you got a, you did this kind of, you talked Mr. SAT into letting you put this question on there. How much sleep did you get? Okay, that will give you some idea. Again, we can question how many people are telling the truth. But on the other hand, it's also probably true that you've got enough people, millions of people taking the SAT, you probably get some good statistics there. But you don't really have access to the SAT. If you want to do this for your science project, you can't go, you're not going to be very successful pulling up ETS and say, put this question on the next SAT. Okay, so that's a limitation for this. Any other ideas how you might do a study like this? Okay? So, if you are a data scientist, what you would like to do is, again, what data scientists like to think about are there data sources that they would have access to that would be available, that they might be able to shed some light on it? And so if we think about what we need to have measures of performance. How well did they do? And we need to have measures of how much sleep did they get, okay? And how might you do that kind of study? Well, some colleagues of mine at Stony Brook did a study like this that I really liked the idea of, okay? They observed the following things that were true. One, they observed that people here know the concept of the NBA, basketball, right? Professional basketball, right? What do we know about professional basketball players? We know they're tall, we know a lot of things about them. But we know that basketball players often keep late nights. Okay, they often, they travel a lot, they like to have a good time. We know basketball players often use Twitter, okay? And we also know that, and Twitter will, when you have a post, you type something and you know what time the post was done. So you know that when someone is sending out a tweet, you know they were awake then. Does everybody believe that? Okay? And the other thing you have about basketball players, you have a measure of performance. The next morning, they've got to get up and not take the SAT, but they've got to play a basketball game. And their job is to get as many points as they can and stuff like this. So what is it, a good test that you can do without asking anybody? But by just kind of doing the experiment by yourself? Well, you can find out who are the NBA players who use Twitter a lot, okay? What days did they have games when they did not admit a late night tweet? What games did they have a late night tweet? What was their scoring average after a late night versus a normal night? And sure enough, your parents are right that performance drops when you don't get enough sleep. When the NBA players found they scored fewer points and fewer rebounds after a late night. Okay? And this is the kind of data science thinking that I like. Okay? I think this is a kind of clever study. You're using data that is a kind of out in the world. I didn't have to ask Mr. SAT for permission to do this study. Okay? All the Twitter data is in some sense publicly available. And if you go to it with the right question, and you go to it with the right, with the clever methods, you can find something interesting. Any questions about that? Or about getting enough sleep, why it's important, how we do these kind of studies? Any questions? Okay? So I think that's a clever example of kind of what data science is on a small scale. Okay, the next thing I'd like to talk about is a kind of changing gears a little bit. So again, in my research, I do study things like Twitter text, Twitter posts. And I want to be able to understand natural language. I want to have computers that can understand natural language. And the question I guess I want you guys to think about now is how you would represent to a computer what a word meant. Okay? First, I ask you guys, how many of you have ever programmed a computer before? Let's try this. I'm looking about half, about as many as don't get enough sleep at night. Okay? If you wanted to represent what a word meant to a computer, how would you go about doing it? What is a kind of, if you have a computer program, somehow there's got to be an idea if it's going to understand what natural language means. You want to understand what a cat is. Okay? How would you explain to a computer program what the word cat meant? Okay, yeah?
I mean, you could assign it to a set of certain objective characteristics, like biological features.
You could say a cat is logically described as a cat has 4 legs, a cat purrs, a cat has whiskers, a cat, when you stroke it, says nice things, okay? And describe the features of a cat, okay? That might be a thing you could do. But that's not really the most useful representation of what a cat means to a computer. You might imagine a picture, certainly for image processing. There's certainly a computer applications where pictures of cats will tell you something about what a cat is. But it's hard to see how you would go from a picture of a cat to being able to know what a cat means, right? Now, when I was growing up, I was told if you wanted to know what a word meant, you would read the dictionary definition, right? Do any of you guys still use dictionaries? Okay, some of you guys know what a dictionary is, okay? There's a definition of what a word is, okay? And you might think, well, a cat is a small domesticated carnivorous mammal with soft fur and a snout and attackable claws and catches mice, okay? I might have thought that would be the useful definition of what a cat is to a computer. But actually, if I am good at explaining the next couple of minutes, I want you guys to come away with the idea that this is what a cat is. See this pattern of red and blue? I want you to look at that and be able to know that that's a cat and that it's just like a dog. Okay? What is that? Okay? That is representing what a word means by what we would call a vector or an array. And what we would kind of like to be able to do is to come up with, since computers are good at working with numbers, you'd like to represent what a word means by a list of numbers. Don't really read this too much, okay? But we'd like to try to come up with a small number of dimensions, represent each word by a small list of numbers that kind of captures what it means, okay? And how do you get these numbers? There's an interesting way to do it, using what we would call a fluency test, okay? So, if I want to try to learn what words mean, or if I knew what words mean, I should be able to take some text and tell a good sentence from a bad sentence. Okay? Now, how many of you think you're good writers? How many of you think you're bad writers? Okay? Now, no matter how bad a writer you are, I think if I took your text and replaced words at random with other words, would the text get better or worse? All of you say you're not so terrible that random changes make it worse. Do we agree? So, my question is, here we have a real sentence. And here we have a sentence where I replace the middle of the word with a random word. Does everybody agree? Now, if I can get lots of good text by reading the whole internet, everywhere on the internet is real text written by real people. There's Wikipedia, there's news, there's all. By making these random changes, I can create bad text. And if I could build a computer system that could tell the difference between good and bad text, that would mean it knew something about the language. Which is the right one here? When I visited New York or when I fixed New York? Does everyone agree that most likely it's when I visited New York? Telling the difference there requires some knowledge of what the words mean. And if I could build a computer system that could tell the difference between these things, I start to have to understand what the words mean. Now, what's here on the screen over here? This is supposedly, okay, two sentence phrases written in Russian, okay, one of which is correct and one of which has a word corrupted. How many people here read Russian? Okay, can you tell which one is real and which is fake? Okay, now I do not understand this. I cannot pass this test, right? These things, which is real, I don't know any Russian, I don't know what these words mean. I couldn't pass this. But which one is the real one? Yeah? Two? Does that mean this one? Okay. Is everybody going to get that idea? So one way that sort of important tool for computers understanding language these days are these things called word embeddings, ways of representing words by these features. And what happens is you basically build a neural network, if you wish to call it that is going to take as input phrases that are either good or bad, and have to try to make the decision, is this a good one or a bad one? Okay? And if it gets it right, okay, we leave the words alone. If we get the word wrong, this was a good sentence and we thought it was wrong, the learning algorithm changes the word representations a little bit, so that it gets it right next time, or gets it closer to being right next time. And after you show it millions and millions of these examples, these things propagate down and you start to get these little numerical representations that capture a lot about what a word means. Any questions about that? I don't know if people find that interesting or not, but now, if you look at that, here are, what you call it, examples of these word representations for some different kinds of words, okay? So again, what are these? Every one of these columns, think of them as a number. I'm drawing it as a color, but you kind of have the idea that it's a color, a number, where the more negative it is, the redder it is, the more positive it is, the bluer it is. When you look at this, what do you see about cat? This is cat again. What do we know about this? Cat look just like a dog? Yes, sure enough, if we look at this, now the representation for cat that I've learned is almost, to our eyes, very, very similar to what a dog is, right? Is cat a color? No, because it's quite different. But all the colors kind of learn similar representations, okay? All the countries learn similar representations, okay? And when you go through this, you kind of are able to build kind of these numerical representations of what words mean. And this is kind of a cool thing, because now you can start to understand what texts mean. And again, we did this for all of English. It's more impressive on some other things, but this is kind of all of English organized by how we represented what the words mean and the words cluster by nouns and verbs and gerunds and everything else you know, okay, based on this kind of thing. Okay, any questions about how computers understand language or anything like that? Yes?
I have a question. When you have a word, it is, I mean, this line is very long, and that's any one person made this word in the line, or how it works. And it is a very long process to explain every word to computer.
So if I have to explain every word to a computer, this is a long process, okay? But on the other hand, if what I'm doing is learning you give me large amounts of text, if the way that I'm learning what the meaning is for every one of these phrases, every time I see it, I adjust the word meaning a little bit, okay? I'm learning all these languages, all these words kind of simultaneously. And so, as far as how much time does it take? It takes a computer an hour or 2 hours to learn a good representation of what English is. But it's not that much work. I'm not sure if I completely got your question.
I can try to explain it another. I mean that these people made this words to computer or not.
People are not explaining, the interesting, people are not explaining to them what a cat is. Okay? It's figuring out what a cat is from all the sentences in this text that mentioned cat. The cat in the hat did something. I don't remember what the cat in the hat did in the book, right? When you were reading that part. You know, somebody stepped on their cat and it did something. Okay?
But there is so much fake information in the internet.
But there's so much fake information. That's true that there's going to be some people who write garbage about cat. Blah, blah, cat, blah, blah. But if I'm reading billions and billions, millions and millions of examples of text on the internet, the number of lies is small relative to the amount of truth, especially on the basis of something simple like what they're talking about with their cat. So how they're using the basic words, the grammar and meaning, almost all the text is basically sensible. And when we see enough of it, we learn what the real meaning is. So the good text outweighs the bad text. And that's why I don't have to really worry about the lies. Yeah.
So if you, I don't, does the computer actually understand the meanings of words? Because from what I understand, if it just got definitions based on text, it couldn't actually hold a conversation, right? It can just.
Okay, so there's a difference between understanding what words mean and being able to hold a conversation. Okay, you could imagine a world like, if all you knew was what words meant, you know, there's things like syntax, the order of words makes a difference. If I gave you these words in a different order, talk, be, Skiena, the, you wouldn't, you understand the words, but you don't understand what I'm saying, right? So there is more to understanding language than just what the words mean. But once you understand what the words mean, you have a good heads up to trying to understand these higher order properties. And so then there are more powerful learning methods that take these basic features, what words mean, and builds on them to start to understand, how to parse grammar, parts of speech, what is the role a word is playing in a, in a sentence, things like that. Okay, so this is an important first step, but this underlies most of this NLP systems built today. But obviously, you need to go higher than that. Yes.
I think that part of what he's trying to say is this is the same way that babies would learn to talk. You don't give a baby a dictionary and just define each word to them. They learn this from experience, from hearing people use things in sentence. A lot of what people might say to them is babble, just random words and whatever.
So certainly through it's sort of learning from experience the same way that the baby does. The baby, I don't think, learns these vectors of 128 dimensions for every word, okay? But I haven't looked inside a baby's head. I don't think that's exactly how they represent it. But it is the same process of learning from examples, yes.
Having said that, can you take your heat map representation of the meaning of the word, and turn it into what would resemble the dictionary definition?
Actually, the short answer is, we've played with this a little bit. It happens to be something we've played with a little bit. So the question of a simpler task of, given the dictionary definitions and given the words, could we match the words up to the definitions based on this? And the answer is sort of, kind of, somewhat, but not as much as you would think. So if you looked at this, for example, you saw that dog and cat were very, very similar to each other. Now, would I be able to look at these embeddings, and what's the difference between a dog and a cat? A cat goes meow and a dog goes woof, right? How would I be able to look at the dictionary at these embeddings and tell the difference between which was the definition for a dog and which was the definition for a cat? That's a more subtle thing, okay? So I don't think I capture everything about the dictionary definition here, but I capture what its role in the sentence is, and I capture a lot that is useful to then build higher order things on. So it's wrong to say everything is in this representation, but there's a lot in this representation that gives me a leg up to build more complicated systems. Okay? Any other questions about language, how you would use these things? So let me show you just a couple of ways that we use these things that are kind of interesting. Let me take a look at this thing. One thing we did was try to figure out what names meant, okay? And so for example, what is your first name? What? Malika. Okay, now Malika tells me that you're probably female, okay? And it probably tells me, Malika, I'm guessing actually, is that, but I'm not sure I know what ethnicity or nationality you are, but it would not shock me if it's a name that's associated with that nationality. Okay? What is somebody else? What's your name? Let's take a look at you. What do we got? A Russian. You want a Russian? Some Russian guy. Okay? You, what's your name?
My name's Alex.
What?
Alex.
Alex, okay? And Alexander with a big R or something like that, I'm going to guess. Okay, so certain names are associated with different countries, different nationalities, different things. How might you learn that? And what the meaning is? So one thing project we did that was kind of fun was we were working with a major internet company, and they had contact lists for people. For a particular person, who did they send email to? And, if you are Russian, quite likely the people you're sending email to are your friends and family. And it would not shock me if the number of Russians in your email queue are overrepresented relative to the rest of the population. The same would be true for if you are a female. More likely you're sending more male to females than you are to males, okay? If you are a kid, I am guessing it's more likely you're sending mail to kids than you are to an older one, right? And basically, if we think about it, we can now think of your email queue, who you're sending mail to, the list of people, as a sentence. We can now try to think of each one of these name parts as being a word. We can think about making random changes, and does it get better? We can learn kind of what name parts mean. And one thing that was interesting, the project we did, was basically map out the meaning of all the name parts. Okay? This is kind of a map of, I will say, the world, where the world is the 5,000 most popular names as appearing on email. And we place them near, now we think of, we have a representation for what each name means as a point in space. We project it down. What's very interesting is you start to see the world clusters. All the Hispanic names are over here. All the Asian names are either here or here. All the, Western Europe, the European names are here. Okay? Here are the two names we have. Why do we have two Asian countries here? Well, some of the names, it turns out, one of the regions is Chinese origin, one of the regions is Indian origin. Okay? Kind of these things capture what words mean. And there's lots of interesting things you can do with that. And because of time, I won't bother to tell you what that is. Let me tell you something else that we did that's with once you can know what words mean by these points that's kind of amusing. Is words change their meaning over time. I don't know if anybody knows that. I'm guessing that you guys know what the word gay means, correct? Do you guys know what gay used to mean? Okay? Well, somewhere along the time, the word gay changed its meaning, correct? It was when I was growing up, gay meant happy. Today, gay means what we know gay means, right? Okay? And can you show how words change their meaning over time? Well, I can train these word representations, and these arrayed points tell me what the word means. Then, I could train it on text from 1900, when gay was happy, and I can train it on text from every 10 years, and see how the meanings of words change. Because as words change, that point should change, and you should be able to see words that are changing kind of fly through space and change what they mean. And this was an interesting example. In 1900, gay was sitting in word space here next to dapper and cheerful, and you see it fly through. And now it is associated with homosexuality and things like that. Okay? And this kind of, what the words mean and how does it change, is the kind of thing you can do once you can capture this kind of thing. Any questions about words, what they mean, how we did it, any of these things? Yeah?
I actually have a question about the name map.
Yeah.
So how many dimensions did you start with here, and how did you choose this 2D projection of the names?
Okay, so we came up, just like in the words embeddings that we had before. We typically will represent a word by 100-ish dimensions, okay? I think in the pictures I showed you, I think there were 64 dimensional embeddings. Typically it's 100, 128, something like that. Then there's a question of, to make a picture, you guys don't see in 64 dimensions. You've got to project it down to 2 dimensions. And to do that, we presumably used a program called TS&E. There's a popular projection method that happened to be used there. But you could do, if you're familiar with these kind of methods, there's all kinds of different methods you could use to reduce the dimensionality further, using linear algebra or some of these other things. Any other questions about language or words or what they mean? Okay. Good. I still got myself a few minutes. Okay. So what I'd like to do here is not talk about that and give you just one sort of set of little advice that, or not advice, my personal opinion. In fact, here I'm going to give you a flashing yellow warning sign. Okay. This is now my opinion. Okay. And I'm going to give you some opinions that may disagree with things you have been told. I've already said you should listen to your parents about sleep. You should listen to your parents about everything. That's important. But I'd like to give you some advice of what I would. My sense is you guys are all very bright, academically excited people who want to go and do more than normal high school students and really learn what something is. what would I recommend that high school students who want to do more about getting into computer science and stuff like that do if they wanted them to get involved? And many times people will say, oh, I should do research projects, okay, with a professor or something like this, okay? And I don't really personally like high school students doing research, okay? Because I think that as a high school student, you should be trying to learn background and broader areas of subjects, okay? More so than getting too intensely involved in any particular thing. This is my pet belief, okay? So listen to your parents, but what I would say is that if you wanted to do something as a project, what I strongly, as a professor, I get called all the time from high school students, typically by teachers who twisted their arm. Oh, Professor Skiena, okay, I need someone to advise me on my research project, okay? And I always tell these people, no, I tell them, go away. But the reason is, I think that in high school it's good to be learning things, and I think it's good to do your own projects, not things that are ideas from professors. You shouldn't be listening to professors. When you get to college, you listen to professors. In high school, you should be listening to your heart about things that you find interesting. And this is a picture of me when I was in high school, okay? And what was my kind of high school thing? I wrote a program to predict football games. Who was going to win a football game. And I wrote a program that was pretty dumb by today's standards, so I'm not really proud of my program on that level. On the other hand, in high school, I felt I learned a lot by building a program that did something I was interested in, which was from learning how to predict football games. And we ended up getting it in the newspaper, and that was kind of cool. But I learned when you predict things that you make mistakes, that you make a prediction of who's going to win football games. One thing you will learn is that you were wrong a lot. And this was a lesson that taught me a great deal. So if you're going to do a project, do something from your heart. But even better, if you're really trying to say, I'm a computer science person, and I want to do something in my high school to make myself better and really start to understand computer science and stuff like that, what would I recommend that people do? I'd recommend that you get involved with a class of programming contests, okay, that are kind of algorithmic in nature. So a lot of what makes computer science interesting is not really programming particularly, but there's problem solving, there's ideas and stuff like that. And there are these websites you can go to where they will let you write a program. They'll give you a programming problem. They will you write your program. It will tell you whether you're right or wrong. And then once you get it right, you get your point, and you move on to the next problem. And these programming contest problems are amazingly interesting, I find. Okay, there are a lot of very, very interesting programming puzzles. And the best way that I would think of developing skills to become a computer scientist, as opposed to just a programmer, is to start to work on maybe trying to get interested and trying to do some of these kind of problems. You know, the website that I probably recommend the most, because it's aimed at high school students, is this usacode.org. There is a kind of a national computing Olympiad that they run. And the best students, high school students from this, compete in the world of this event, of these kind of programming challenge problems. But they're a lot of fun. You learn a lot of what is really real computer science by doing it. And so if you're saying, what should I do if I want to do it? I say, start playing with these. And I say, even read my book called Programming Challenges, which is the book that teaches people how to do these kind of problems. So I recommend that all of you get interested, all of you read my book, all of you tell your parents what you want for Christmas, okay? And maybe you'll find these exciting. Okay, so at that point, I think I will say I've got my time done. Any questions about, you know, algorithmic programming, computer science, natural language, anything like that? Yeah.
So in the example earlier, when you said that it learns kind of the meaning of the words based on the
places that it's on the internet, I would suppose.
Yeah.
And there are words that have contradicting meanings or contexts, such as if you were to have the name Trump, there will be maybe a third of it that says it's the president, a third of it that's saying he's the best president, and a third that's saying good president.
Okay, so the question is a question about when you learn from data, these word meanings from data, what about contradictory meanings? And then contradictory meanings or alternate senses is the way that I would be putting it about. So one thing is, when you use the word Trump, before we say good or bad, what I want to say is president or something that you do in bridge. Has any of you ever played the game? Ever heard the word bridge the word Trump used as a word in Trump means to beat somebody, I guess, or to do better than something. Okay? How do you know when someone is referring to, should the word vector for Trump be near presidents, or should it be near words like beat and spades and Trump and bridge terms? What?
You could use capitalization.
You could use capitalization, but sometimes that's not a complete word. The truth is, you want the word to be next to both of them, okay, for different senses. And this is one reason why we're using 100 dimensions, let's say, to represent what a word means. Because words mean many different things, right? And so what I will say is that this representation is, because it's high dimensional, it can capture different senses of what a word means. And I would like to think that if you were learning about Trump, you would probably read some things that say good, some things that say bad. You would probably have some, like to have all of these things kind of encoded in the representation. That there is controversy and that that's what you would like encoded in this. Okay? Yeah.
So you mentioned they use around 100 dimensions. So how do you determine how many dimensions to use? Because if you use too few, you won't be able to differentiate. But if you use too many, I guess you have overfitting.
Right. So that's exactly what the problem is. So how many dimensions should you have? If you have, as you said, too few dimensions. If I say that a word means 5 dimensions, you don't get a very rich description of what words mean. If I use too many dimensions, as you say, there's a danger of overfitting. What does overfitting mean? It means that I've got the space to store basically the exact text that I have seen, and I won't be generalizing very much from it, okay? If all you knew about the word cat was, here's the word, here's a million examples of the word cat, okay? And I'll tell you what a cat means, I can't really use that. I'm going to be really just fixed on that. I don't generalize from it. How do I know how many dimensions to use? Typically, you're building these as a first step to building something more interesting on language. Like there was a question about trying to understand syntax, for example. And one way to tell is you use the number of dimensions where the syntax recognition stuff does well. Okay, if you use too few dimensions, it won't do well. If you do too many dimensions, it won't do well. Typically, for 100-ish dimensions, it does about as good, pretty well, and I'm not worried about overfitting. So we usually crank it up to 128 dimensions and don't worry about it. Yeah.
So for words that can have many different meanings, for example, for the word right, where you could have the direction, like the sense of fallacy, or something else like political rights.
Right.
Is it possible for the single word to have several vector representations, or would it have a single?
Okay, so now what you would really like, what you're now saying is something very interesting. So you would like to say it'd be better than having Trump, the word Trump, be half president, half, bridge term. Okay? You would like to have, could I separate which were the presidente Trumps and which were the bridgey Trumps, and have a different representation for each? If I could do that, the representations would be more meaningful. But it's hard at first. If this is my first step to try to understand what the language means, recognize that making this distinction at any given point is a difficult test. So the short answer is maybe you first build a representation where every word has its own meaning, right? Maybe if you really care about that, then go and say, look at which words seemingly have multiple meanings. And try to figure out, then go back to the text and say, well, this is meaning A and this is meaning B. And maybe retrain on that. So the answer is that is hard and sometimes done, and but that's hard and that doesn't work as well as we might like it to work. Okay? Yeah.
How much memory do you need to memorize all the words?
How much memory do you need to memorize all the words? So that's interesting. So one way to think about it is certainly to memorize all the text in the world. This is a big deal. This is why Google is a big company. Okay, so the amount of text in the world that you can get access to is certainly, raw text is in the terabytes, huge amounts of data. On the other hand, think about how big my representations are. How many different vocabulary words are there in English? Does anyone want to guess?
300,000.
What?
300,000.
300,000 if you start considering very rare words. The average person, I think, knows about 40,000 words or so. But there's also a question of are names different words or, So bottom line is, a good thick dictionary. Remember those dictionaries that I read that you guys don't? Those have about 100,000 words in them. Okay? So 100,000 words by 100 numbers each. This is not that much memory. I mean, it's big by the scale of your phone, but it's not big by the scale of my laptop computer. Okay? So this is actually not an unbelievably expensive representation. You're taking the whole big text, the exciting thing, all the text in the world, and boiling it down to these numbers that are relatively concise.
But you said that these words are 100 dimensional. We have 100, and that means that each word is much more than 100.
Well, I'm going to say that each word, so again, I'm not representing the text this way, I'm representing the vocabulary this way. So think about me as building a dictionary, okay? And it's 100,000 words, where each word is only, 100 numbers or so. And this is not an unbelievably amount. It's probably about the size of the old dictionary that I had on my desk. Because figure the average definition is 100 words long or something like that. It's about the size of a normal dictionary. And it gives me a reasonable representation of what these words mean. So space is not really a problem with this so much. Okay? I take a lot of data in, I boil it down, and I throw the lot of data out. And that's why I don't have to worry about space. Anything else? Yeah, like this. Okay? So, okay. So anyway, thank you very much. Thanks very much for listening, and these are very good questions. And if anyone wants to talk, I'll be here for a while. I'm happy to talk.